Yeah, hi everyone. Yeah, my name's Innes. I work for IO, just covering the Java side of things. Yeah, we're really lucky to have Steve along today for a talk. Steve, do you want to say a quick words, just a quick intro about yourself?
Oh, yeah, sure. So, yes, my name is Steve Poole. I work for Red Hat, and I have for 2 weeks, I think. I used to work for IBM. Um, so I talk about Java, and the reason I talk about Java is because I've been doing JVMs and stuff. I always say since before it was one. So before Java really existed, I was lucky enough to be working on JVMs, and I've been doing it ever since. And part of that journey has been to learn about all sorts of other aspects related to Java. And then, as a side, the reason this talk exists is because I took a sort of sabbatical and spent 3 years running an IT team and a European team, and I learned all about security and came back and went, developers need to know all about this, which is why this talk exists.
Perfect, thank you. Yeah, so just a quick rundown on format. So Steve is going to deliver his talk, and during it, if you've got any questions, do put them in the chat box, and I'll butt in and ask any questions, just so we're keeping, I guess, the interactiveness of the meetup, albeit virtually. But yeah, do feel free to say hello, ask any questions during the talk. I think that's it. Anything from you before Steve cracks on?
All good to go.
Cool. Right, let me try and share my screen. So I think it's that one. That looks. Can you can you tell me what you see?
That's good. We can see your screen.
Good. Yes. So you can just see it. So okay. Cool. I have no idea what you're seeing. So this talk originated several years ago, and I've been doing talks like this around this to explain to people about cybercrime, because developers are just. I wouldn't say we were ignorant, but I actually say it was worse than that, and that we have a view of what security means, and we think it's not our problem. And so this talk is really to help you understand a lot of what's going on, what your problem is. This is not the scariest version of this deck. I have another version that I could use, but that's not good to do during the daytime because you'd be really scared. It's an interesting talk. So what I've got here is I'm going to take you through. So let's see if I get it to work. I'm going to take you through how cybercrime really behaves, how it works, what's going on, how to think about it. And then at the back end of that, we'll talk a little bit about what you might do as a Java developer or just a general developer. So most of this is going to be the scary bit, and then we'll talk about the back end about what you could do to make this a little less dangerous. So we'll start with this thing. We'll talk about fake news. There's a lot of misconceptions about cybercrime. You see it in the press all the time, and you probably have views in your head about what it's about and who's doing it. So the first thing is there's this idea that the people who are actively involved in cybercrime are these sorts of guys. You know, they're teens and they're in their bedroom, and that is true. There are a few of them, but they're not really where the money is. The reality is that most of the cyber attacks that we talk about that have real impact on you are driven by organized crime. Okay, it is very self-evident that the people who are attacking us are well organized, and these may be state actors or it may be criminal rings, but at the end of the day, even if it's a group of people getting together, they are developers, and they have got together and they have built the tools and they're using them, and they share this information among each other to attack you. So that brings you on to why they're doing this. There's this, some people think that, okay, the hackers are just doing it for fun. You know, that's what it's all about. And the answer again is no. What drives people to attack you? What drives people to get into your systems? It isn't for fun, though again, there are people doing that. The reality is that organized crime is the most profitable type of crime in the world. Now, I want you to get your head around this. So this chart you're looking at, the green line is past and future predicted drug trade. Okay, so illicit drug trade. It has been bubbling around half a $1 trillion for some years. And it's predicted to continue bubbling along that line because it's sort of manageable. Obviously, nobody wants it to exist, but it's basically manageable. Think about the movies that you've seen and the stories you've heard about the drug trade, where you've seen, you know, people measuring their money by weight, and, you know, burying, you know, payloads of this stuff in the ground, or buying the most expensive cars. That's the drug trade, and that's $500 million. 2016 was the year where cybercrime took over. It became more profitable, and since then, it's climbed and climbed and climbed. Interruption? No? Okay. And the reason that this is so profitable is nobody ever gets caught for it. It's almost impossible to catch somebody doing cybercrime. Right? You think about how hard it is to prosecute somebody who did attack you from a different country, or even if you could find them. And they do get found, but they're very, very rare. Okay, so it's really well paid, easy to do, with minimal downsides.
Steve, I've got a question from the floor from Yaz, if that's okay.
Yeah, sure.
Is there a standard or basic definition of cybercrime?
Is there a standard? I'm not sure if there is a standard. There's a range of things that we could talk about, and I have a slide in a minute which I'll talk about some of the ways they attack, and maybe that will help understand. But I don't believe there is a standard that I could point you to.
Cool, perfect, thank you.
Yeah. Okay, so the other misconception that people have is that they think they'd notice, right? Because a lot of the time, where you think you see things, you go, oh, you see spam like this, right? We all get this. I got this a couple of years ago, and it was great. What I really liked about this particular one was that it equated this new BMW at $500,000 and an Apple laptop. So obviously an Apple laptop is as valuable as $500,000. So we get these spams, and you know that at the end of the day, it's funny because you spot it. But bear this in mind. It is not aimed at you. This is aimed at people who will fall for it, because this scam is designed to capture people who are basically stupid and greedy. There are much more sophisticated attacks that are designed to get to you, right? And you will see them, and you could easily fall foul of them. There are ones where people have spent time researching your industry, your business, your company, and will use social media processes to get into your system and send you something that you will believe in, right? And there's a whole setup around that space. Now, I'm not going to talk about social media hacking in this talk because it's not relevant to what we want to talk about. But the point is that you think you'd spot this, and the answer is, well, no. So the poster child for all of this sort of cybercrime is Equifax. And it's the one, unfortunately, to the Equifax guys, that people use because of what happened. And it's a perfectly great example of how it works. So you will not notice. In fact, the whole point of organized attacks is not to let you know that you're being attacked. So what you see is the timescales. You can see that right at the beginning, where it says March the 9th, it says first who I am. So the vulnerability that Equifax had allowed people to get into run remote code. Once they can get in and execute arbitrary remote code, they can then wander around the system. So they get in, and then they spend a couple of months wandering around trying to understand what was valuable. And once they finally got something, which got access to data, then they just started stealing it. But they are trying very hard to make it so that it won't get noticed. It took months for Equifax to realize that they had this problem. These guys are professional. They are not going to attack and own your website. They're not going to change pages like that. They're going to get in and they're going to do what they need to do. And hopefully, from their point of view, they're not going to attack you. Now, that leads you on to this thing, which is people go, oh, but nobody would attack me. I'm not valuable. And yes, this is a real website. Don't ask me why, but it is, okay? And it's an example. It's a website, so a website's valuable. So here's what people steal from you. So they will they will steal your data, but it's not the only thing they'll do. They will change your data, right? One of the things that came out of the Equifax situation, which was revealed, I think, in the last year or so, was the fact that data may have been added as well as taken away. Because if you have a credit system or you have anything like that, then adding in fake users can be really useful. You imagine that is if you got into your system as well as stealing credit card numbers, what happens if they added a bunch of fake accounts, right? They could do those sorts of things as well, and that would be useful to them. You imagine Amazon being hacked and a whole bunch of new accounts being added, and then later on somebody comes along and uses them and buys stuff. You know, it's more than the simplistic of steal your data. They will also try and crash your systems. The denial of service attack type thing happens quite often, but I wouldn't worry too much about it from what we're talking about here, because denial of service attacks are either associated with some sort of ransom attack or is literally kicks. Though there are signs now of them system attacks being used by state actors to literally practice cyber warfare. But these things have happened. Now, the next one, use your compute power. You have compute resource. We've seen an explosion of people getting into systems and just using your CPU to do Bitcoin mining, right? And one of the really good targets that people like to use is Jenkins servers. If they can get into your Jenkins server, they will steal some of your CPU, right? Because with things like Jenkins servers or any CI/CD system, you normally expect it to be fully loaded. So you won't notice that it's running at 100%. And if 10% of that CPU is being used to mine Bitcoin, you may not ever notice. And then, of course, they're going to do this, and then they're going to get through and try and get through your system into somebody else's. And that's a bigger talk in itself. So that's what's going on. And then people go, yeah, we're safe. We have a firewall. Okay. And of course, that's not true. Having a firewall is not the answer. And at the very least, it's not the answer, because at somewhere you've exposed an application, and whether it gets out to the internet, you're still putting out some exposure. You've got some API, whatever that's being used. So the simple answer is the bad guys are looking for vulnerabilities in all of these places, right? And we'll talk a little about vulnerabilities. So your answer to this has to be defense in depth. So there is no silver bullet to this problem. You've got to look at it from the point of view of every single thing that you do has to be thought through from a security point of view. So you need defense in depth. You need systems that will help you compartmentalize what's going on. You need detection. You need to know that you've been attacked. And more than that, you need to have alarms. You need to know that things have actually happened. Because there's no point having nice little things in your log saying, hey, we've been attacked, if nobody scans for them. Right, so now I'm going to talk about how they actually attack you. And this is the main classic one. So there are multiple ways that you could be attacked, but from our point of view, as people who create code that runs on servers, this is probably the most obvious way. There are others, but this is the one that you probably will have the most impact on. So I call it drive-by because it's literally that. So when you see the movies and you see people doing bank heists or whatever, there's a map and there's a plan, right? And there's all those wonderful excitement. And that's not how it happens. Cybercrime isn't like that, right? They don't start with a plan. They start with a script. So imagine this. Imagine a burglar trying to open every door and window of every building across the planet 24/7. This is what's happening now. Every single system that is public facing and those that have been compromised are being attacked potentially 24/7. There are spots out there that all they're doing is trying to find entrances, and they are running constantly. So what do these guys do? How do they create these scripts? Well, the first thing they do is they start off with vulnerabilities. So the most important takeaway in all of this is that if you don't look at your vulnerability stance, then you're going to get attacked, because vulnerabilities are the things that everybody drives off. So here's one, okay? This is the Equinox failure, right? You get CVE, it tells you things. It tells you what versions of software this thing is applicable to. So what the bad guys do when a CVE comes out, they'll look at this and they'll go, okay, so how do I work out what piece of software you've got? Now, there are a lot of ways of doing it. One way in this particular instance turned out to be, well, if I know that the vulnerability was associated with a design change, and the design change meant that a particular type of file name changed. So that meant if you scanned for the old files, you'd find systems that had vulnerability. So you go to Google, right? And you just do file type action. And when I ran this, whenever it was a few years ago, you get a bunch of hits. There's your list of potential candidates, right? And I'm start working through that. But it's not the only way. Okay. I can go, I can look at the response headers that your server gives back when I make a connection. And I can look at what it gives back. So here's the response headers you get out of Chrome at a particular service. But look what you can see in the middle of that. You can see server Nginx 1.12.2. Thank you very much. As a owner of this service, you've told me what version you're running. And because of that, I can now go and figure out what vulnerabilities you've got. Okay? So that's what I do. Right? And when I say this is almost totally automatic nowadays. Right? So vulnerabilities, what's out there? So I can go to CVE websites, of which there are multiple, and I can find all sorts of vulnerabilities. And I'll be looking for something that I can make use of. More excitingly, I can use websites like this. This is showdown.io. Showdown.io is as it says, the search engine for the Internet of Things. Whereas Google will index the HTML pages, etc., that are served, what you get with Showdown is literally every device that can be found. It will go through and it will index. And it captures all sorts of interesting things, like where you are in the world, what your IP addresses are, of course, what ports you've got open. And if Showdown knows what that port is meant to be serving based on the number on this, it'll ask it and record the data. Every single device on the internet that can be found is available to you in Showdown. Right? And I can go to Showdown and I can say, tell me all the servers that are running Java. And it'll do that for me. It'll give me a list. And I'll say, tell me all the servers that are running Java, I don't know, 1.6. And you'll find a bunch of people doing that because they didn't realize that they were being indexed. There is so much information available to you. Here's a little thing. I use this. It's called Wappalizer, which is a browser-based plugin. And you can use this. And then any website you go to, you can ask Wappalizer to tell you what it's running. And it'll look at what it's got in terms of what's coming down into the browser, for sure. So you'll see some of the jQuery and things like that. But also, it'll also work out what it thinks is running at the other end. I can work out, using all these tools, what you're running, where you are, what OS, what your IP address is. I can look at your SSL certificate chains and work out whether you've got any breaks in those. It's all sorts of ways, totally automatically. No human beings involved. Right? And I can connect that to all the vulnerability databases. So SNCC have them, others have them. There's all places you can go to get the connection between what the system is running and the potential vulnerabilities. And then, as if that isn't bad enough, you can then use ready-to-go exploits. Nowadays, if there's a vulnerability published, there will be an exploit published. So this exploit is uses Metasploit, which is the sort of the standard tool. So what you're seeing is a sort of Ruby-esque type code. And literally all I have to do is type in the IP address of the server that I want to attack into the code and get Metasploit to run it. It's that easy. And I've got more. Because not only can I work out things like that you've got particular vulnerabilities, I can work out for any particular type of vulnerability what's the right thing to do. So here's another website where the vulnerabilities are classified by their type. So you can see in the middle, it's like code execution, overflow, denial of service. So basically, it's really easy to build a bot to exploit these weaknesses. So if I want to build a bot that's going to bring your server down, then I've just got to figure out which one connects with the version of software you're running. If you've got the vulnerability, then I can make use of it. Okay, so that's the biggest thing. That's them getting to your door. And the vulnerabilities will work. The vulnerabilities that they're going to exploit, some are going to let them get into your system. But even when they get into your system, it doesn't stop there. They will also be looking at other ways in. Because once they've broken the firewall and they're inside your premises, so to speak, they've still got to figure out how to get into your applications. So let's talk a little bit about how that works. So you can break it down into 3 pieces, and we're only really going to talk about the middle one. We'll touch a little bit at the first one. So basically, they're going to try and figure out how your security works. They're trying to take it apart. They're going to do the same for your application. And then social engineering is all about what can I find out about your application from what you say on Facebook. And you'd be surprised what people say about systems, even simple things like what's the name of the system you're working on, and that can give people clues. So we're going to start with the first one. I'm going to start with security disassembly. So the first thing is, are you using HTTP? If you're using HTTP, then this conversation's over because you've already lost. Right? So that's the first thing. Now, the second thing is, just because you're using security, you've got encryption, doesn't mean that it's completely safe, because there are always vulnerabilities around. And sometimes you get vulnerabilities that are actually to do with the encryption itself. And that's why you've seen in recent years when we've had big pushes to move up the SSL levels and things like that, because they have discovered protocol problems, design problems. And for some reason, these all get nice names. I'm not quite sure why, but there we go. The thing you have to remember is that you can't be certain that the data you're giving out or the data you're receiving is coming over any secure connection. There are so many ways that people can get at the data. So you have to bear that in mind. You cannot assume under any circumstances the client that's on the end of the wire that you're talking to is a good guy and that hasn't been compromised. Whether it's a mobile app which they've taken apart, or they've got man-in-the-middle attacks, or the classic of injecting malware, cross-site scripting, etc. There's always the potential. So you have to have that in your head about what you do, how to deal with those situations. And then the greatest gift that we've given the bad guys is unconstrained use of REST. So we love REST because it's wonderful architecture. And we publish documentation about how the API works. Okay. The problem is you've just told the bad guys how this works. Right? And so what they'll do is they'll just go, right, I'll just guess. I'll guess how to use your API because I know that you're using REST. So I know probably that I can call an API and I can pass details in and I can expect to get stuff back. And they'll sit there and they'll try different verbs and different combinations to get into your system, right? And they'll look at their cookies and the headers that will come back and they'll go, oh, what happens if we change this? What if we try this? They'll do this all the way, trying to figure out what options, what configurations will drive your code differently. It's just that. And one of the things they're trying to do is break your system because errors are really good because if I can get an error out of you, then I know that I've made a difference. And one of the classics is them trying to figure out which of the APIs they're calling are from different systems because you give back different return codes. So there's differences between 404 and 503 basing on what service you're using. So one of the classics is, if I can get a 404, then the chances are I'm talking to whatever service you've got that's serving up static files. So the question then is, can I use things like you see here with the dots in? Can I compromise your system and get access to files that you weren't expecting me to do? And then if I do get errors back, they're great too, because errors give me insight into whether I'm on the right track. And also because errors are very helpful, because a lot of the times errors are being put out like this for you as a developer's benefit, is you'll also tell me what version of software you're running on. So that's a double bonus. So the way that they will attack your API is this thing called fuzzing. And the OWASP guys, which is a really good place to go look and learn about this stuff, is a whole set of configs and thought processes about how to do this. How do I attack your system? How do I reverse engineer your system? How do I call your system with data that's not quite what you expected to get your system to behave differently than you intended? Okay. And it is fully blown, as in this is a professional space. A lot of what you're seeing are being produced by people who do this professionally, the pen testers who you may hire occasionally to come and attack your system to find the holes. Well, all that information is going to be, and those tools is used by the bad guys and more. So there are all sorts of tools out there. And the big list of naughty strings isn't a bunch of swear words, by the way. It's basically a list of words and that people know may crash or do unusual things to your API. Things like zero width spaces. So chuck unusual Unicode at you and see what happens. Right? It's all there. Fuzzing your APIs is built in. And it's not just REST, it's everything. If you have XML payloads, you have binary payloads, if you're processing images, you're processing anything, there will be ways to fuzz that to see whether we can break your API. And it's just built in. It is widespread. There's 20 odd years of thought process into this that's out there that's been turned into tools. The bad guys, as well as trying to get into your system, will also look at what data is flowing between them. If they can get part into your data flows, then they can understand, reverse engineer the code, the flows. That helps. There's a whole bunch of tools out there that can do that. The one you're seeing there, MITM proxy, is a nice little one. And it's just really easy to get going and see what actually happens. And you combine that with a Wi-Fi gateway, and it's quite scary to see how much data can be found. They'll do other things. They'll read the code. If you're on GitHub, or even if it's internal GitHub or wherever, if they can get access to it, they'll go looking for it. So they can do things like this, where they'll go to Google and say, can I find your specs because you're publishing them, right? And they'll do things like this. I suspect that we have all Googled for something like this. We've all looked at how security is being used, and we've all tried to figure out how to turn it off. We've all had that situation where we're trying to access a server, probably an internal server, and it's got some South sign certificate. So what do? Well, we Google for things like this, and then we learn how to turn things off. And quite often we write code like this, right? And normally at this point you have a few people in the audience going, yeah, I've done that. Yes, it's what we do. And we do it because we think it's the right answer, but it's not the right answer. The reason it's not the right answer is because everybody's doing this. And if I went to Google and did those searches, which I have, sorry, to GitHub. So look, you can do the search yourself. Go to GitHub and scan for trusting manager or trusting trust manager, and you will get whatever the number is, you will get lots and lots of hits. These things are coded into the dependencies that you use. Right? So the attitudes that we have to turning things off can be codified and can become features inside the dependencies. And we don't scan dependencies for these sorts of things, we just use them. It's that easy to find these things. And I use Google, and the bad guys use Google for all sorts of things. I'll go looking for data that you wasn't expecting to be exposed. You don't expect your web things, your config files to be exposed, but they do get exposed, right? And you find information about URLs, and they call it. And look, you know, here's a JBoss, I think it's a JBoss control console, which somebody inadvertently left available because they published data, not they intended to, but it did. It happened. How about this? This is called a dork. So dork is, for some reason, a term for a Google search. And if you Google on dork, you'll find a whole bunch of them. Some very nicely structured search terms to find you all sorts of things. So this one says, find me all the ones that have got 8080 and JMX console. Okay? So that's all the unauthenticated JBoss servers that are out there. Okay? It's that easy. It was a mistake that somebody made, but the bad guys find it. Right? And this one, where people have inadvertently left a password file. So the JMX remote, the default passwords, or in this case, not the default passwords, but somebody made it available on, and it wasn't intended to be made available, but it was found by Google. The bad guys find these things. Okay. And we make it worse. As developers, we make this worse because we do things like, we put things on the command line because it's easy, like, you know, -d options. And the problem is that goes in the logs. And the bad guys might accidentally have access to the logs. And the logs may also be in your iOS or your Android application. The logs may be put there, which they can be found. It isn't intentional, but it happens. Right? And then test endpoints, they're great ones. Here's a file with some service descriptions of test endpoints that people put, because sometimes the way that we want to test something is we want to have some test endpoints rather than the real endpoints because they're going to be driven differently, etc. The problem is that quite often people don't put security around test endpoints because they're for testing. And that's okay if they never ever see the light of day, but they do see the light of day. They either get discovered via Google, or maybe the bad guys discover them on your system another way. Our behavior makes it so much easier for the bad guys, because as developers, we're quite used to doing things to make our life easier. Right? And the question is, the statement is, that's a bad thing to do. If you do that unconstrained, if you don't think about the consequences, you can run into all sorts of these sorts of problems. Here's a really good example. We don't even think about this, right? So if you've ever inadvertently checked a password into Git, the question is, can you take it out and remove it? And the simple answer is no, because once you've committed it and shared it, it's in the Git repo. You can delete it, but it's not really gone because it's in the history. And if you go to GitHub and you search on things like remove password, you find, well, look, when did I do this? A couple of years ago, so it's probably changed. Just 400,000 hits of commits where people think that it's okay to do this. It's our brain thinking that this is okay because it's safe, because there are no bad guys out there. And the answer is there are loads of bad guys out there, and all of these actions contribute to their ability to get in. So the way that they're going to get into your API, into your system, is by all these sorts of things, right? They are looking for how you behave. They're looking obviously for vulnerabilities. They're looking for the endpoints, the information, and they're going to fuzz it. They're going to take your stuff apart. Right? They're going to work it out because that's what they do. And there are lots of tools out there to help you do this. So much of this is automatic. So if you want to know more about how the types of ways that you can be attacked, the OWASP guys have lots more information. But I want you to understand at this point, this is what happens. It's really easy to be found and to attacked, and therefore you have to do something about it. And then when I get to this point, people go, yeah, but it's okay. We have time. We've got time. We can fix this. Time to exploit. You can see a little chart, and it tells you that in 2006, the number of days between an exploit being published and it actually being used was about 45 days. And by the time it got down to Equifax, well, let's put this in numbers. In 2006, it took 45 days from a vulnerability being published to being exploited. Nowadays, it's 2 days. Well, actually, it's not. It's 2 seconds. If you have a public-facing application on a public cloud, so those IP addresses are all known, they are being constantly monitored. You can expect when you put up a server that you will be probed almost instantly. And if it can figure out that you have that vulnerability, then the system, you'll be attacked immediately. There's just nothing you can do about it. So you do not have time to apply vulnerability patches of certain types, because as soon as you publish your data, it's going to get exploited. And of course, the challenge is that you need to know what types of vulnerability you need to deal with. And the answer is simply, you don't have time. You have to keep your vulnerability management as far as possible at the top. You have to be fixing all your vulnerabilities. Every vulnerability fix that comes through, you need to apply. Otherwise, you're in a bad place. So what else can you do? Well, let's move on to the last bit of this talk. What's your role in all this? So understand that security can't be tested in. It's an easy to say, but it's one of the biggest takeaway is you have to be thinking about how your system is going to be compromised from the beginning. Okay? And you have to have that all the way through your process. You have to think about how you design software and how you write code so that it cannot be compromised, or you can, at the very least, put roadblocks. So here's a couple. So think about the validation that you're expecting to happen. Here's some Java code where I put in a bunch of files and paths. And you go, okay, who's supposed to catch the fact that I'm doing something that's a bit suspicious? Well, if you go through all the various steps in the code that's going through, you go through all the various bits and pieces. You can go to the spec and you can see what file does. And you can go look at the code and you can see what file does. So file calls file system, and file system calls the native code. And the native code doesn't do any validation, therefore Java doesn't. So when
Steve,
yes?
Sorry, Steve, can I ask you a question?
Yeah.
It's from Yaz. Are there any vulnerabilities that are specific to cloud-hosted systems such as Azure, AWS, Salesforce?
There probably are. Almost everybody has unique vulnerabilities, but they're moment by moment. So they come, they get fixed, and another one gets found. So the simple answer is everybody has them, and there are always unique ones. So the answer is yes. Right? But they come and go. They come, they get fixed, and then they discover a new one. Right? So there's not like, I can't tell you right now there's 10 or 1 or 5. They're just, but yes, every cloud has their own unique set. Right. So in this case, validation. So what I'm saying is, it isn't just about the data that you get in. It's also about the data that you consume and your assumptions about who does something. So if you expect a piece of dependency to behave in some certain way, write tests for it. Because then if that behavior changes, you'll catch it. If you make an assumption, test it. And if you know that you're expecting some behavior in this area, then make sure that you've got tests to prove it continues. Don't just rely on the underlying code, because the whole thing about vulnerabilities are they are mistakes. Right? Nobody can do this by design, it's just mistakes. And then other things, like if you're writing code and you're dealing with exceptions, we're very good at writing code that looks something like this, where we go and create some config file and read it in and say, oh, well, if I get an IO exception, it's because the file doesn't exist or something. That's okay. The problem is that if you get an exception that's not what you expected, you did nothing with it. Okay? If you expect a certain type of exception, then write code that catches it and then report anything else that you get. And it's all the way through this. Exceptions, we all go, well, yeah, I know what I'm expecting. And that's fine. But if you write code that assumes some generic failure is the way to catch things, rather than being more specific, you can get into all sorts of problems. Because what you want to have in code like this is where it's not expected, you want to make sure that you understand what happened, because it may be an accident, it may be some code you're doing is behaving badly, or it may be a bad guy who's exploring your system. And all the way through this, have to make sure that you figured out how you're logging and writing alerts for what's going on. Okay, it is really critical that you think about providing information to the logging system and to other tools to capture the fact that your API is behaving in ways you weren't expecting. And all the way through this, it's all about writing code defensively, because what actually happens in reality is quite often the path through the code that we write is driven by the data that we get. So we quite often let the code path be driven by the data. And if the bad guys fuzz the data into different ways, they can drive your code in places that you weren't expecting. So you want to think about the concept that the code, that when you get an API request, it isn't a command, it's a request, and that you validate it both as individual parts of data, but also as a state change. And are you willing for your application to go through that sort of state change? Anyway, so here we are. There are more things we could talk about, but I will stop here. But really, we're not in the greatest position as developers, because we're beginning to understand the challenges, but it's a long way to go, because we need to make changes to the way that we behave. And it's hard, because as developers, we are all brought up to be a lot more trusting about things that we use. The code that we use, the information that we take, we assume that everybody is trustworthy. And we have to think much more about flipping that and looking very much more on how these bad guys are going to get into our system, and how we can build systems that have this defense in depth. So I have a few more slides, but I'm basically just going to end up saying the same thing. So I think I'll stop there and see if there are any questions. Anybody scared? Are people still online?
Do feel free to mute yourself if you've got a question, rather than just put it in the chat box.
Stop sharing. So I'll tell you what, I will put up this one. This here. So this is the summary page. But I mean, there's loads of words, but what I just want people to understand is people who are out there trying to attack your systems are professional. Well, they have lots of good tools. They are very good at their job. And so much of what happens is the bad things are happening because of the mistakes that we make, which we all do. But it's also about how we think about security. Quite often, when we talk to people about security, what do you think of? You think of encryption, maybe. But actually, security is all about this other aspects, about you writing code defensively, about you testing things correctly, and how you think about designing your applications. So it's just so much harder for bad guys to attack you. And at the end of the day, right now, if you make your system slightly less vulnerable than somebody else's, they're going to move on. Because all this automation tooling is trying to find a way in. So if you have your vulnerabilities up to date, then you are less likely to be attacked than anybody else because you're less of a target. But that doesn't mean that you can afford to not look at proper security design in your software, because all it takes is one of these bots to get into your system, and then a human being will follow along and will start rooting around.
Hi, can you hear me? Okay,
yeah.
Can you hear? Yeah. Just this is just a comment. A lot of projects are kind of designed around, meeting the user need. Yeah, so we've got a whole load of, here's what the customer requires. Go in, do this code. However you do it, whether it's waterfall, agile, however. And usually, security issues tend to be kind of relegated to what are generically termed non-functional requirements, which tend to kind of be forgotten about or left to a separate domain that doesn't get as much exposure in the project sort of delivery stage of it. More often than not, it's kind of given to a section that's kind of a dedicated security personnel, and they do their occasional pen testing and so on and so forth. Yeah. It's kind of really difficult to get all of this on board, particularly when time is limited and developers are kind of pushed down the create the functions that we want created in the first place. It's just kind of a general.
Oh, no, I agree. So as a developer, then the simple answer is to focus on the bits that you can affect, and that is design your software and being able to share more information. So logging or things like that. Thinking about these situations where what happens if your code gets driven differently. Your code quality goes up if you think about things, as I said, about the API passing in requests rather than being commands, and you think about state transitions, and you look at whether or not that's valid. Those sorts of design principles can make your code higher quality. Right. But in general, yes, we quite often, as you say, people will assume that security is somebody else's problem, and that it's vulnerability fixing. Yeah.
I mean, I have a background in development. My main role right now is as a Scrum Master, and product owners have no bloody clue, about security. They just know what they want in terms of, how they want their application to look and what button to click and what have you. Most BAs tend to not be technical, so they tend to just reiterate or parrot what the product owner is saying. And I found it's kind of almost always dropped in my lap, having to think about the non-functionals, over and above the usual thing, like make sure there's enough load balancing and failover and all that kind of lovely stuff. Yeah. And the real intricate bits like security tend to kind of be forgotten about unless I make a real concerted push on it.
Yeah. So what you're saying is what lots of people have said, and I agree. That is the challenge we have. The number one thing that needs to happen is the vulnerability management. If you have a good posture on that and you've got tools to discover them and fix them, you're going to be a lot better than not doing that. But then in terms of getting sort of management involved in dealing with this, it's really hard. Partly because of this fact that security has this weird non-existence. We talk about security and we put it in quotes, and it's somebody else's problem. So I've done these sorts of talks, and I do Java security workshop with SNCC and Zonotype and others. And we always had this something at the beginning where we talk about this. And it's always the bit where people go quiet, because once you start explaining this in more detail about how the bad guys behave and what they're doing and what tools they've got, and you get some use cases up in front of people, then you begin to people begin to realize just how bad this is. But to be honest,
are there any specific resources in terms of where we can go, particularly around things like code review? Because I can't really see this being picked up in terms of code quality, coding defensively and what have you, until it gets to the to the code review stage, where somebody is actually picking up on these things.
Yeah, there are tools. I haven't got a slide with me, but there are tools. There are the security tools that you can write plugins for your IDEs. There's sort of find bugs type tools. There's a whole bunch of scanning tools out there that are either open source or commercial that will scan your dependency configs.
If there's any chance you can do us a list, that I'll be very grateful.
I can do that. Or I tell you what might be even better is why don't we talk about getting you, say, somebody from SNCC, Brian Vermeer, to come along and talk to you about that whole side, because he's got a lot more day-to-day practical knowledge of how to actually do that.
Okay. If the group want to host a session like that, I'd be up for that. Yep. But thank you.
Okay.
I think there's quite a few people who's put up examples in the chat box, which might be of help.
Yeah, I've noticed a couple of them. I've used things like SonarQube and what have you, but they rely on a lot of configuration, and a lot of people kind of the security side of it isn't part of how they configure things like SonarQube to report back on things like code quality. That they tend to kind of is it camel coded, is are variables declared in a particular way and all that kind of lovely stuff. But I am aware of kind of systems like this. Yeah.
I think getting somebody like Brian Vermeer along would be really useful to you guys, because he would, let's say, this is his day-to-day life, and right. If you want latest and greatest about what to do, then that. And yes, he works for SNCC, which does this professionally, but he and I do talks, community talks around these subjects, but he would be the best person. And I'll ask him. It won't take long.
Yeah, we'll get you on it, Steve.
Yeah.
Any more questions from anyone else at all? Or? No, seems about it. Well,
apologies for the questions. Yeah.
No, these are good.
Not at all.
Yeah,
not at all. I'm assuming that's it. If anyone does have a question, feel free to just interrupt me. But yeah, obviously, thank you everyone for joining us. Steve, thank you very much for your time. I have to say, I think that was probably my favourite Java meetup so far. I really, really enjoyed it. Really interesting. So thank you. And yeah, Steve, any suggestions you have, or any kind of friends or colleagues, we'd be definitely keen to hear them. I think we have got our November and December talks already lined up, but we're always here for more in the new year. So yeah, it'd be great to hear those from you, Steve.
Yeah.
Our next talk I think is lined up for the 17th or 18th. Just need to double check, of November. So not too far away. Just finalizing as well whether we'll do it at lunch or in the evening. If you guys have any feedback as well, feel free to pop that across to us. But yeah, we'll pop the recording out on the website and on LinkedIn as well. Yeah, I think that's about it from me. Steve, again, thank you very much. Really appreciate it.